All right, welcome back, guys. This is Professor Roldan with Explorations in Math. This is Chapter 4 Review, or online it's called the practice test. So we're going to go ahead and get started. Just a couple things before we begin. Number one, if you do this review, you should be fine for the paper test that's going to be in class. Also, you need to watch the video for 4.5 that discusses some history, and that will be on the test as well. Okay, so let me repeat that. There's some history that is going to be on the test, a couple questions of history that you can hear and read about from the 4.5 video. So make sure you watch that. Okay, so let's get started here. In number one, the system of numeration in which the number 1, 2, 3 is written is the blank system. And so remember that our numerals and digits come from the Hindu Arabic system, okay? Chinese is very different. Roman numeral uses certain letters, and the Ionic Greek as well. So let's take a look at the Egyptian numeral. Here, number 2. So we have the symbol for, the first symbol is for 100,000. And then we have 4 symbols for the 10,000, so that's 40,000. Then we have 2 symbols for the 1,000, so that's 2,000. Then we have 1 symbol for the 100. We have 3 symbols for the tens, so that's 30. And then we have 1, 2, 3, 4, 5 symbols for the 1, so that is a 5. Okay, so final results will be 100,000, 42, 135, and that would be this one right here. All right, number 3, the Egyptian numeral. Below, we're going to go ahead and do the same thing. So we have 1, 2, 3, 4, 5, 6, 7, 8 symbols for the 1,000, so that's 8,000. We have 3 symbols for the 100, so that's 300, and 1, 2, 3, 4 for that, so that's 8,304. Okay, let's take a look at number 4. So we have 321, or 321. So this is 300 plus 20 plus 1. So we need 3 of these. We need 2 of these, and we need 1 of these. And that would be option C. Okay, next page for me is number 5. So as you read a Roman numeral from left to right, if a smaller number comes before a larger number, you should, so here's a key thing, a smaller number comes before a larger number. So usually it comes after, that's when we add, but if it comes before, then we subtract, okay? Okay, then we have the Roman numeral MCMLX111. So M is 1,000. So let's rewrite this here. And you can look right here as a reference. So remember that these references will be given to you for the test. So you will not have to memorize these as along with Egyptian numerals. Okay, so M is 1,000. And then we have CM, because C is smaller than M, so that's 100 minus 1,000 minus 100. And then we have L, which is 50, and we have basically 10 plus 3 is 13. So we can just combine those last three. So 1,000 minus 100, that gets you to 900. And we get 1,963. Okay. Here's another one to practice with. CCC, that's the most you can repeat, is 3 times. And that's 100. So this is 300. And then we have XL. X before the L means we're subtracting 10 from the 50. So this would be 40. And then that's 5 plus 1, that's 6. So 346. Next we have 999. This is a tricky one. And most likely this is going to be on the test as a challenge problem. So 999. So the closest we can get to that would be 1,000. Then we got to go down from that. So the 999, I'm going to break this up. So 900, the only way to do that is to subtract 100 from 1,000. So we're going to take that 100, put it before the 1,000. And since this is multiple choice, we can clearly see it's this one. But if this was not multiple choice, then you would have to finish this up. So 90 would be 100 minus 10. So put the 10 or the x in front of the 100. So that's xc. And then we got, we can't do 5 plus 4 because that's too many. But we can do 10 minus 1. So that's going to be 1 in front of the x. Okay. All right. There's a few more here. So we have 139. 100 plus 30 plus 9. So the 100, that's just a plain C. 30, we can do 3 x's. And the 9, we can do 10 minus 1. So a 1 first and another 10. So this is the 30, this is the 9. Okay. Next page. Okay, so now we're in number 10, and this is just fill in the blank. And trying to remind you that right there is called, 8 is called the base. Okay, and then in this, remember all this stuff is about place value. So 4 is, okay, so these place values for the 7 or base 7, for base 8, let's take a look. So every first place for any base is the ones place. And the second place in this case would be 7 to the first power. I'm sorry, 8 to the first power. And then the third place would be 8 to the second power. Okay? So the 7 represents 7 times 8. Okay? Which is actually 56. Okay? If it would have asked you about the 5, which is in the third spot, then the answer would have been C. Okay, or that last one. Let's take a look at 12. Number 12 and 13, we're going to be converting. So this is base 5. So base 5, first place value is always the ones place. The second place would be just 5 to the first power, or just 5. So this is really worth, in our system, 1 times 5 plus 1 times 1, which is 5 plus 1 is 6. Oops. Okay. Now real quick, just to point that out, how is that possible? 1, 2, 3, 4, 5, 6. In base 5, we're looking for sets of 5. So 1, 2, 3, 4, 5. There's your set of 5. So that represents the digit for the 1. That is the second place value. And then this is the remaining. So you got one set of 5s and one remaining. And that's where we get the 1, 1 from. 1, 1, base 5. Okay? Just as a quick reminder. Number 13. Oh, I can just leave that open. So base 9. So you can just say, hey, this is the 1's place, this is the 9's place, and this is the 9 squared, so that's 81. Okay? So we have the third place value is worth 9 to the second power, is 81. The second place value is worth 9, and the first place value, which is the 7, is worth 1. So 3 times 81, 243, plus 18, plus 7. And we add up these three numbers, and we get 268. Okay? Now number 14 is base 2. This is the sort of strange, but it's all about place value. Whoops. Sorry about that. So we have the ones place, 2, 4, and then 2 to the 2 to the second, 2 to the third would be 8, 2 to the fourth would be 16, and 2 to the fifth would be 32. Okay, so those are the place values for each of those spots or places. So we have 1 times 32 plus 0. You can skip the zeros if you want, because that doesn't really add to our quantity here. It's basically saying there's nothing worth 16. So it's up to you. So we have the 8. We have the 4, we have the 2, and we have the 1. So 32 plus 0 plus 8 plus 4 plus 2 plus 1. And this is going to be, so 15 plus 32. It's 47. Okay, so this is converting are looking at the place values of other bases and converting them to our base. Now, we're going to take our base and convert them to another base. So the way we do this, so in our base, we're looking at quantity, so 68 in quantity. So we can actually say that's 68 items that we have. And in base 8, all that means is we're looking for sets of 8. Okay? So to look for how many sets of 8 is in a number, that's called division. Okay, so we're going to take, first we're going to say, all right, well, what's the base 8 worth in the first space? So base 8 would be always ones place, and then the 8, and then 8 squared will be 64. All right, and then the next place is too big for just a 68. Okay, here we can see we have a set of 64s in 68, so we don't need the third place value. The fourth. So we know our number is going to have 3 places. Okay, so first we're going to say, okay, how many 64s are there in 68? There are 1, the remainder of 4. So we know our first digit is going to be 1. Then we take our 4 that we have remaining, and it's divided by our next place value, which is an 8. Well, 8 doesn't divide into 4. It's not enough. So there's nothing worth that much there. So we try it again with the 1s, and of course 1 divides into any number. So 1 divides into 4 times, and no remainder. So our answer then that we get is basically the result of those 4 numbers. Okay, so that would be option C. Okay, let's take a look at number 16. So this time we're looking at base 4. Okay, so base 4 has 1's place, the 4's place, 4 squared place, which is 16. 4 to the 3rd power, which is 64. 4 to the 4th power, which is 256. Oh, 256 is too big. We don't have enough. 103 as a quantity is not enough to make a place value in the 256 spot, which is the 1, 2, 3, or the 5th spot. We don't need that. Okay. So I'm going to repeat our division, starting with the highest. So to get this place value, we need a 64. How many 64s are there in 103? And I'm pretty sure you know that's only 1. Then you subtract. Okay, so 103 minus 64 is 39. Okay, what about our next place value? 16. 16 goes into 39 twice. That's 32. Remainder of 7. What about our next place value? 4. 4 goes in 1 time. Remainder of 3. And then our last place value is 1. And you can see the answer right there. Okay, 1, 2, 1, 3, base 4. Okay. 817 for us. What is that in base 8? So we have the 1's place. We have the 8s, the 64. So 8 to the 3rd is 512. That is as close as we're going to get to 817. So we know our answer is going to have 1, 2, 3, 4 place values in base 8, and we start our division. So that 4th place value is 512. How many 512s are there in 817? That's definitely once. So 512. Then we subtract. It's 305. Then we're going to divide by 64. So 305 divided by 64 goes in 4 times. So 4 times 64 is 256. And then we subtract that from 305, get 49. Then we continue the process. We're going to divide by 8 now. And 8 times 6 is 48. Remainder of 1. 1 into 1 goes in once. So our final answer then is going to be right there. 1461. Okay, next we have our addition and subtraction problems to do. And we're going to add up these as normal, but we cannot go over the amount that we have, because once we hit 4 or above 4 in quantity, we've just made a set. Okay? And so just as a reminder, for base 4, if you have 4 of a quantity, that's 1 set. So that right there is 1 set of 4 is no remainder. Okay? And if you have 8, that's 2 sets, so that would be 2. Okay? Sets of 2 with no remainder. Okay? If there's 2 remaining from a set, then that would be now 22. Or, I'm sorry, 2 base 4. So 1 plus 1. And that's 2. That's not a set, so we can write 2. 2 plus 3 is 5, which that we just made a set. So that right there is 1 set with 1 remaining. Okay? So we're going to write 1, 1. And then we have 1 plus 2 plus 1, which is 4, which is a complete set. So that's going to be 10. Okay? Or not 10, but 1, 0. Final answer, 1012, base 4. Now let's take a look at base 5. So we have 4 plus 3, which is 7, which means we've completed a set. 1 set of 5s with 2 remaining. So we're going to write the 2, carry the 1. Now we have 1 plus 2 plus 4, which is the same thing. Put the 2, carry the 1. And of course 1 plus 1 is 2, and we don't have enough for a set. So we just write 2. Here's base 7. First column is 4 plus 4, which is 8, which means we completed a set. 1 set of 7s with 1 remaining. So that's a 1, 1. Carry the 1. That's 1 plus 5 plus 6, which is 12. Still have 1 set. And remainder will be 5. So we're going to put the 5, carry the 1. 1 plus 6 plus 5 again. Same thing. Okay, so now let's look at subtraction. Here we're going to borrow borrow the amount in the base that we're working with. So if we borrow one set here in 21, we're going to be borrowing a set of 8. Okay, so we're going to be borrowing from the 6, making it a 5. Instead of 6 sets of 8, it's 5 sets of 8. And now we're going to add that 8 to the 4. So now this becomes 8 plus 4 is 12. 12 minus 5 is 7. And then 5 minus 3 is 2. Let's take a look at a few more. 1 minus 1 is 0. And now we have to borrow sets of 4. So we're going to take 1 from there. And now there's no more in that place value. But we're adding 4 to this place value. But we need to borrow from that 4. So we're going to make them now a 3. And give a set to this next place value, which is 4. So now we have 4 minus 2 is 2. 3 minus 2 is 1. And so this is 120 base 4. 23. So there's a lot of stuff there. Let me just rewrite it. So 2 minus 1 is 1. We're going to borrow from this set and give a set over here. Then we're going to borrow from this set and take our 3, which we're borrowing, or one set of 3s is 3 in quantity. We're going to add that to this one to make it 4. So now we have 4 minus 2 is 2. And 2 minus 2 is 0. So this is the final answer. Okay, number 24. Number 24, it says, when determining the product 24 times 19 using duplation and mediation, the 24 is blank by 2 and the 19 is blank. Okay, so remember on the left side, this is the left and the right, this one is the one where we divide by 2, this is the one we multiply by 2. So this is, the 24 is divided, he's on the left, and the 19 is on the right, so he is doubled. Okay? So that's reminding you of the process. And now we can see it in action over here on number 25. And number 25, basically, you can see the 13 being divided into 2 and the 19 being doubled. Okay, those are all the same numbers. The question here, number 25, is on the last couple steps, you're supposed to, or the fourth step, you're supposed to cross out the even numbers on the left side and its corresponding partner on the right. So the only even number that we have is 6, and so this would be the correct response. And then from this, you just add up your remaining numbers on the right side. So that's 247. Okay, so now we have to do one all by ourselves here. So 27 and 17. Here we're going to divide. Here we're going to multiply. So 27 divided by 2 is 13.5. Drop the 0.5 and just make it 13. 13 divided by 2, 6.5. Make it a 6, drop the 0.5. 6 divided by 2 is 3. 3 divided by 2 is 1.5. Drop the 1. Drop the 0.5. So now we need the partners for the on the right side. So 17 plus 17 is 34. And then 34 plus 34, or double, you're just doubling it, 68. 68 times 2 is 136. And then 136 times 2 is 272. So now we're going to go ahead and cross out even numbers. So the only even number is 6. So we're going to cross out 6 and its corresponding number on the right. So we add up these numbers on the right that were not crossed out. Add them all up. Our calculator. And we get 459. Okay. Now, our next method would be the lattice multiplication. And that's what these grids or lattice boxes or whatnot. So 4 times 423. Now, it is better to put the 423 on top and the 4 on the right. And so in this case, they put the 4 on top and the bigger number on the right, which makes more of a column look, and that would be this one. 4 times 4 is 16, 4 times 2 is 8, 4 times 3 is, so here, 4 times 2 is 8, 4 times 3 is 12, and then we add up, so the answer is 1692. Okay, so make sure you know how to do this for the test as well as the duplication and mediation. So 72 times 81, we just do that. 72 times 81. And we start doing our cutting. Okay, so now we're going to do 8 times 2 is 16. 8 times 7 is 56. And then 1 times 2 is 2. And 1 times 7 is 7. So now we're going to be adding so the 2 comes down by himself. And then the 7 plus the 6 is 13. Carry the 1 here. So then we have 1 plus 1 plus 6 is 8, and then the 5. So there's our answer. Okay, almost done. Last of all, we have Napier's rod. So Napier's rod is basically the same thing as lattice, except we're lining up the rods. The rods have multiples of all the numbers from 0 through 9. Of course, 0 is not really important, but in this case, the rod would be, the index would be 8, and then you would line up the rods for 1. So this would be this would be the multiples of 1s. This would mean the multiples of 5. This would be the multiples of 6, and all the way up to 8 down here. And so basically, you would just look at this, but you can just do this in your head, right? So this is 8, this is 40, and this is 48. And so our answer is that one. Okay? Now, what's the final answer as far as multiplying? Well, we have 8, and these two make 4. These two make 12, carry the 1, 1248. Okay, so the last thing, you would just do 4 times basically like that. But I would just do the lattice way. So the lattice way would be 92. Here's your 4 here, so that's going to be 8 and 36. So the answer is going to be 8, 6, and 3. All right. So that is it for our practice tests. We just went through all the problems in chapter 4, and hope you did well. If you need to see the video again, please watch it. And what I recommend is doing the practice tests along with me, so you can know what's going on if you happen to forget, and see examples as you're doing it. And don't forget that the last video, 4.5, that has information on history that will be on the test. Okay, so hopefully you're, let me just write it down. So history questions on the test from, not the, but let me do from my 4.5 video. All right, so let me know if you have any questions. See you soon.